Hello, Professor Densmore, Hanlon, and anyone else who may watch this video. My name is Youssef, my partner is Christian, and this is our Lab 4. Christian, please share your screen so we can see the code.
All right, so let me share my screen for the code. Here we go. So this mini project this time is a digital clock with modes of changing the clock and changing the alarm and also changing it into an AM PM display. So let's get to some of the interesting modules that we have in our whole like clock module. So the first one is the clock divider. So to get us a quite accurate like clock time, we divided the clock that's provided by the FPGA by like 100 megahertz to make it a 1 hertz clock to make it as accurate as possible to an actual clock. As you can see, we just divided it here, and then it will output like a clock with a frequency of 1 hertz, which we will use in this digital clock module. So in this module, we'll output hours, minutes, and seconds, and also like the LED for the alarm. And it will also receive inputs from set clock and set alarm modules, where it will like try to synchronize between those. And then it will use the clock from our clock, like the divided clock from the clock divider module. So it's all here. It will set the hours, minutes, seconds, and then it will increment like accordingly. And then the next interesting one is our melee clock module, like our melee machine, like finite state machine for our clock modes. So we stated that we have like 3 main states here, which is our main display, and then our set clock display, and then our set alarm. So this melee machine um, will go through each states based on the inputs, which will be based on the switches like on the FPGA, which we'll show you all later. And then the next one is our set clock module, where Youssef will explain more in depth about what we do with the set clock module.
So our set clock module, it's very similar. We have our hours and LED to show which one between the minutes, seconds, and hours we're incrementing. The left, right, up, down input, which is just initialization for buttons. And obviously everything's going to be based on the clock. We have 4 different states. We have a second state denoted as 00, minutes as 01, hours as 10, and then our hold state as 11. And then beginning, we have some initializations. Now, can you go down? This is the second state right here. We also have very similar syntax for both the minutes and the hours, but I'm just going to go through the seconds because we don't have 15 minutes. We only got about 5 or 6. So when we press the up button, we want the second value to go up. So you'll see the incrementation of +1. And if we ever get to 59 seconds, we will push it up to 0 because we can't get 60. When we go down, going down on the value, we want it to increment down -1. And if we ever get to 0 seconds, we can't have negative seconds in time, so we will set it back to 59. Then when we want to go left, we'll go from the second state to the min state. And all the LEDs, the LED is going to highlight the middle one because that's where the minutes are in a clock. They're in the middle. And when we go right from the second state, we will go to the hours, which is all the way the far left. That's why it is 1, 0, 0. Now, I will go ahead and show a demonstration of our FPGA. Right now, I have it preset, and then this is just the clock running normally. I can also go ahead and change this. Right now, in military time, it's 009, but in 12-hour format, we should see 12:15 in the morning, and that's what we get. The clock hasn't changed, it didn't reset, it stays the same way. Now I have some preset times. Right now, this is the set clock, and as you can see, I can increment all of these. I'm just incrementing the hours for now. I will set my clock to 8 hours, 39 minutes, and 29 seconds. So, excuse me. Once I go ahead and put this switch down, you will see the clock start from this value and increment up normally. As you can see, it starts to go up. It was at 29, now 30, 31, 32. This is the alarm. I will set the alarm at 8:40, 39. I can go ahead. We'll probably have to wait a bit. Maybe I can move. I can just leave it as is. 8:39:29. Probably shouldn't. Now we gotta wait a couple extra seconds. I can probably go ahead and make the alarm a bit closer. Make the alarm. Oops. Make the alarm a bit closer. So now we don't have to wait too much time. But as this clock runs, we can see it work. Obviously, if I were to go to 12-hour mode from military time, this would be 8 o'clock in the morning. Ooh, my phone is on 20% battery. If I go push it up, it'll be right there, 8 in the morning. This doesn't really change over time, and this doesn't really change between the 12 and the 24. As the clock is going, we're waiting for the alarm. We will see a red LED pop up over here. Once our alarm is set, we just gotta wait like 10 more seconds or so. I know the wait is excruciating. There we go. There's our red LED, and then we can just go ahead and take it off just by pressing the button. Some takes a couple times, but yeah, that's our FP. Oh, one more thing. If we go ahead and we set our clock, if we set our clock to something bigger than 12, like for example 14, there it'll set. This should be 2:39 p.m. And if I push this lever up to do 12-hour mode, you will see that it is now 2:39 p.m. Now we will go and talk about our successes and failures in Lab 4.
Right, so thank you, Youssef, for like the presentation, that display. So we have a couple of successes and failures in implementing our FPGA design. So the successes are like our implementation and using finite state machines for like changing between modes and also changing between like hours, clocks, and minutes for like when we're setting time or setting an alarm. Also, another one of our successes is how we managed to implement a quite an accurate clock, which goes second by second as like how an actual clock will go by. So it will have the correct frequency. And then we also have a couple of failures, which Yusuf will explain as well.
Christian talked about how our clock goes up incrementally by a real second, which is true. But one thing we weren't able to do was that we weren't able to get the real lifetime. Right now it's 11:25. If I wanted to go ahead put that on the FPGA, I'd have to do 11:25 p.m. It wouldn't like update as it went. Another thing is that we, other than making the clock realistic, as in going by seconds, we didn't really expand on the general requirements of Lab 4. And finally, as shown when trying to turn off the alarm, it took me a couple times to go ahead and press the button. And we believe it's because there's a synchronization problem between the buttons and the clock. But in general, we showed our code, we showed all the different modes and how the modes work together, and we showed various examples of the alarm and of the different times between 12-hour display and 24 display, as well as described our successes and failures. So thank you for watching all the way through the video. My name's Youssef. His name's Christian. This is our Lab 4. We hope to see you during our project. Thank you.